طيب today we will do the chapter 2 اللي هو vectors, linear combination and linear independence. In the beginning we have to know what's the vector, and already we did it before. It's just one column, okay, or one row, and a dimension of it is the number of elements in that column. So n elements, so this is n vector. Here we're dealing with vectors like that, and here one column. And in particular, we're dealing with vectors in Rn. That is, all the numbers here are real numbers. Okay, so it is a vector in Rn. Okay, type same as the matrices before. Same rules are here applied when you are adding vectors to each other or multiplying a row time column times scalar and etc. For instance, x is this one, so it is a 2 vector in R2. This is a 3 vector in R3 لأنه في 3 element, correct? So 3 vector in R3, correct? R2 R3. This is, it's the pen. Okay, this is كأنه مثلا في here ال R2 معناها ال XY plane, correct? This is the X plane, ال X, this is ال Y axis. R3 اللي هو حيكون عندنا ال X وال Y وال Z وهكذا, صح؟ sorry. Okay, yes. ال X وال Y وال Z وهكذا. Okay, so يبقى this is a 3 vector in R3 and etc. Type of equality. Now when we say that 2 vectors are equal, same as when we deal with the matrices, 2 matrices are equal if each element is equal to the corresponding. So here في vectors, if x1 is equal to y1, x2 y2 وهكذا لحد xn is equal to yn. If this happened, okay, طبعا عندهم نفس dimension, then they are equal. X and Y, we say that are equal. How we add? Each component we add it to the corresponding, صح? If I need to add to have x plus y, so x1 plus y1, the first element, the other x2 y2 and هكذا لحد the last xn plus yn. طيب, how we multiply by scalar? The same as in matrices. You multiply each element by that number. And if we need r multiplied by this vector, so this r should be multiplied by each element here. So this is r for xn. Now this is x and this is y. If we want 2x plus 3y, so that this one you multiplied by 2 and this one you multiplied by 3 and then not up. So it's going to be 6 وهنا times 2 4 here 2, correct? And then you add up. This is the first, and here this one you multiplied by 3, so you're going to get this. And then after that we add 4 plus 6 10, 6 minus 3 3 وهكذا 14. So this is the vector 2x plus 3y, same as we did in matrices, and here it's only one column, so operations are easier. And all the other rules for matrices also it holds for vectors. Addition of matrices was commute, so if you added this to this, it's the same as adding this to that. Also, for vectors, you can start with adding any two, either this plus this, and then the resultant to this, or you can add this two, and then u plus this, and etc. u plus the vector 0. Vector 0 معناه شنو؟ كل الكومبوننت هنا بس 0 0 0. So this is the vector 0, correct? So u plus 0, it's clear it is equal to 0 plus u عشان الخاصية اللي هنا دي, which is equal to 0. و u plus minus u, again it's 0. So all the same as in matrices, the small letters are for what? For scalars اللي هم real numbers, while الcapital is representing شنو؟ الvectors. So you can do for this one, first add the two vectors and then multiply the resultant vector times this scalar, or even you can commute. So you can calculate first C for U and then C for V. You got this, and then after that you add this vector to that vector and etc. Clear? lastly 1 for u is equal to u. Now we want to define the linear combination. What is the linear combination? If we have some vectors, okay, x1 x2 لحد xk, and then if I can find a new vector x by doing what? Linear, يعني linear operation, يعني I multiply the first times a number, let's call it C1, and the second times a number, let's call it C2, and then here the third time C3 لحد the last one times a number, let's call it CK, a real number, and then add up this. So x is equal to C1 x1 plus C2 x2 plus C3 x3 plus لحد الأخير CK xk. So we got x from the vectors x1 x2 x3 by doing شنو؟ just linear combination. هل في vector هنا x square ولا x2 square ولا x3؟ no. هل في x1 في x؟ no. correct? So by linear combination like this. So what do we say? We say x is a linear combination of the vectors x1, x2, x3 لحد xk. Okay? So a vector x in Rn. احنا بنتكلم هنا in this chapter only we're dealing about the vectors in Rn. Type it is a linear combination of these vectors in Rn if we could find some scalars, okay, or numbers that this one I get it from this as C1 x1 C2 x2. So if this happens, then what? Then x, yes, we say that true, it is a linear combination of this. Our aim here to find these constant. If I want to test that x is a linear combination of this, I have to find these constant such that this addition will give me my vector. Here, for instance, this is an easy example. If we have the vector 2 minus 3 or 4, is it a linear combination of these vectors or no? Is it a linear combination of these vectors or no? Yeah, it is a linear combination of them. Why? Because I need this to be 2. And I know that I'm going to add these up, okay, after multiplying them by a constant. So at the end, I want to have here addition and here addition. But this one, okay, what should I multiply by? This, what should I multiply? And this type to get 2, I should do the operation here. But this is 0 and this is 0. So it's clear if I multiply the other here by 2, I'm going to get this one to be 2. Now this is minus 3. Okay, so I have to look after what? After this part. So this is 0. Whatever I multiply by, and already I multiply by 2, this is going to be 0. Correct? And also this one 0. So from this one, it go from this vector. So this vector I can multiply it by minus 3. Yes. And the last one I can multiply it by 4. Yes. So what I'll get? I'll get 2, 0, 0 plus this one I multiply times minus 3. That is 0 minus 3, 0. And then the last one times 4. So 0, 0, 4. And clear, when you add up, you're going to get the vector 2 plus 0 plus 0, which is 2, 0 plus minus 3 plus 0, which is minus 3, and then 0 plus 0 plus 4, which is 4. So yeah, I got this one. Yeah, but what is the C1 and C2? C1 is 2, C2 is minus 3, correct? And C3 is 4. So yes, I got x بتساوي 2x1 minus 3x2 plus 4x3. Is it a linear combination of these vectors? Yes, it is a linear combination. And this is a trivial example, and it's easy. Correct? So it's clear that yeah, x is a linear combination of this because I got it in terms of x1 and x2 by doing, you know, just a linear operation like this. Clear? So this example is very easy anyway. Type now, determine whether this vector is a linear combination of x1 and x2. Is it a linear combination of them or no? Okay, that means what I need a constant c1. I need a constant, okay, c1, such that when I multiply this one by this number and I multiply this one by this number, I should get that one. Okay, so here I will assume I have c1 here and here c2. These numbers, when I multiply the first time this one and the second, so I'm going to get that. That means c1 in the vector 1, 2 plus c2 times the vector 3 minus 4. This should give me the 5, 5, the vector 5 and 0. If this happened, I could find this, or I found these two numbers, then I'm done. I will say that this vector is the linear combination of that. يبقى my task here to find لو هو he asked me this is a linear combination, يبقى my task is reduced to شنو? Find these vectors C1 and C2. طيب, from this step, what do we have? Now we multiply C here, C1. So what I'll get? I'll get that. I will get that. Let me reduce this. طيب, I will get that C1 plus هنا the other part to C1. Correct? This is the first vector. Yeah. Plus, what is the second? 3C2 وهنا minus 4C2. Correct? Is equal to what? Is equal to 5, 0. Now we do the addition. So this is equal to C1 plus 3C2, C1 plus 3C2, and then from the second one, 2C1 minus 4C2, correct? This should equal to the vector 5 and 0. If we could find this C1 and C2, we are done. طيب, but we said that two vectors are equal if what? If each element is equal to the corresponding. That means we have C1 plus 3C2 should equal to 5. And 2C1 minus 4C2 should equal to what? Should equal to 0. Now tell me, what is this? What it reminds you with? بيذكرك بشنو؟ بيذكرنا بشنو؟ What if I put for you here? I said x plus 3y is equal to 5. 2x minus 4y is equal to 0. What is this? What is this? ده شنو؟ Isn't it system of linear equations? It is system of linear equations يا جماعة, صح ولا لا? Yes. So this will be system of linear equations. So this is system of linear equation. يبقى now my problem is reduced to solve, to find the value of the unknown x and y, and here which are C1 and C2. So how we solve a system of linear equation? We solve it by first putting it as augmented matrix, and then after that we solve. يبقى now what remains to solve? I will find the augmented matrix, which is going to be 1, then 1, and then 3, and then here 5, Yes, and then from the second row, 2 minus 4, and then 0. So I need to solve this system for what? For C1 and for C2. What we do? We have to reduce to echelon form our triangular form, correct? So this is, and then we start reducing. Okay, so I reduce it and I reach here. So just the same step to solve the system of linear equations. Okay, so I reach here. So this is here C1 and this is C2. إذن 1 في C1 plus 0 في C2 is equal to 2. إذن طوالي that is C1 هتساوي 2. And from the second row, C2 is equal to 1. So I got a constant such that when I multiply 2 times the first and C2 become by 1. 1 times this, I should get 5 and 0. If you want to make sure that this is true, just multiply it. Type 2 في 1 by 2, 2 في 2 by 4. Plus, now the 1. 1 في 3 by 3, 1 في minus 4 by minus 4. Add up. This is 2 plus 3, it is 5, and 4 minus 4, it is 0. So yes, I reached to this one. يبقى this is correct. يبقى yes, 5 and 0 is a linear combination of this one. And actually it is equal to what? 2 اللي هو 2 x1 plus 1 في x2. يبقى is it true that this vector is a linear combination of the others? Yes, it is, such that x بتساوي 2x1 plus 1x2 and I'm done. يبقى كل problem what we do, we start putting لحد ما we reach to put the linear system as an augmented matrix, and then after that all the steps like what we did before in the previous chapters. Okay, just a minute. Okay, طيب يبقى what I'm telling you, instead of you do all these steps, if he asks me خلاص احنا we clear how we go, how we proceed. I'm telling you what you do. Look, if you want to write this as a combination of this, what you do? Just find the augmented matrix where this one is going to be the part A and this is B. An augmented matrix must always, this is, we put the coefficient matrix here and here we put the vector B like that, and then we reduce to the echelon form. Yeah, so what's going to be your A? You want to write this in terms of which vectors of this. So these are going to be the part A. 1 or 2, 1 or 2. 3 minus 4, 3 minus 4. What you want to get? 5 and 0. So this is 5 and 0. So if you understood, no need for all these steps and all these calculations. Just directly, if he asks me to check whether this is a linear combination of this, so immediately I'll write the 1, 2, 3 minus 4, and I need using them to find the vector v0, 5, 0 by doing a linear combination, and my task is going to be find C1 and C2, and I am done. If I could find the C1 and also I found C2, خلاص, I'm done. Clear? Clear? Let me do this one, okay? Just 1 second. So determine whether the vector x, this one, is a linear combination of this and this and this. Do I have to go and then find, I write here C1, x1 or C2, x2, C3, x3, or then I do the calculation and then this should equal to -5, 11, -7. Plus, I knew where I'm going to reach. This is going to be the A part, and this is the B part. So I want to check, is it or no? Is it a linear combination or no? So 1 minus 2, 2, and then the other 0, 5, 5, and then 2, 0, 8, and then I want, using this, can I find minus 5, 11, minus 7 from them by doing a linear combination or not? So that means I'm checking, I'm trying to find this C1 and C2, and this is C3. I have to solve this system. I have to solve this system. طيب, okay, solve it. Reduce to the echelon form. طيب, I reduce to the echelon form, I reach here. طيب, I reach here. Is there, can I find C1 or C2, C3 as a, no. Why? Because 0 is equal to 2, and this is impossible. So, no solution. I cannot find this C1, C2, C3. So that means I cannot write this vector in terms of this and this and this. It is not a linear combination of them. I cannot find it by doing linear operation here on these vectors or in terms of them. Is it clear? Okay. Type, okay. We stop here.